Hot mic. Good morning. How's everybody doing this morning? We're down here in the bunker again, and we're going to go over some pretty cool stuff today, utilizing two pieces of the Powermetrix equipment at one time, actually, to do some verification work. We also are getting a chance to let Jarrett stretch his muscles a little bit. We have, for the first time, the use of 5 cameras at one time. Of course, that creates for Clumsy John more tripping hazards. So if things start crashing or hitting the ground, that's all on me. But I'm going to do my best to not do that. But as you can imagine, that creates more cables laying around. But yeah, so of course, he's got it working really well. So we've got actually 5 cameras on this shoot for the first time. We're going to go over some pretty cool stuff today. Before we get started, you know what I'm going to do. We're going to pray. And I just wanted to say, if you get a chance, for all my folks out there that pray with me, if you go to westparkbaptist.org, and on there, it's the one in Tennessee. I think there's another in another state, but my pastor, Sam Polson, had just a really, really unbelievable sermon on what's going on with the world right now, you know, between the news and everything else. So I would highly recommend that you take a look at that. I love it because I can watch them while I'm out on the road, and they also do live stream, but they're on there, it's saved, you can look back at them. And I just wanted to say, you know, we're looking at all these, it's kind of hard. I've actually cut my TV off. I don't want to look at any of that stuff anymore. It's gotten too crazy, but you see all these politicians, people that are in positions of what, you know, we would think are power, and we hear the things they're saying and all this craziness that's going on. You know, it's hard sometimes to believe that God's in control, but remember, God even let Pharaoh become the greatest and most powerful man at that time on the earth, and we know what happened with the whole Red Sea thing. So he actually used it to show the real power and to glorify Him. So I'm going to go ahead and pray real quick right now, and then we'll get started. Father, thank you so much for this time today, and we just appreciate we said the technology to be able to reach out to folks that we can't see right now. We miss our Powermetrix family right now. And Father, we know that you're in control of all things. And sometimes things look like they're just spinning out of control. But you always have a plan. And we just need to stand on that and stand on our faith and understand that you are in control, even when they were in the boat and it was a storm like they had never seen before, because they were fishermen. They were used to being on that sea and seeing storms. It was just... And Jesus was sleeping, taking a nap. So and when they woke him up, that's what he said. He said, you know, where's your faith? So we have faith in things that we can't see, because the things we do see don't give us a whole lot of faith these days on the television, Father. So we just lift this country up to you. We lift all these people up out there that are working in our industry, our Powermetrix family, putting themselves on the line for others. And Father, most of all, thank you so much for what Jesus did, dying on the cross for us. Without that, I couldn't even pray right now. So all of these things I say and ask according to the will of the one who paid it all, my brother, Jesus Christ. Amen. All right, let's rock and roll. So, I've got the clicker again. So I'm going to say we're verifying a pre-wired meter socket with a PowerMaster. Actually, PowerMasters, because we're going to use 2, one to power and one to read. So you're going to get to see it. It's pretty cool. So let's go to the next one. This is Series 11 of the quarantine webinar series, COVID-19 series. So today we're going over, like you said, that pre-wired meter socket verification of it. We won't have one on Thursday, and then we will resume again on next Tuesday. Okay. Here's our agenda for today. We're going to simulate a load through the meter socket with an inserted meter, and so then we're going to verify the wiring using vector diagrams, and then we're going to verify the quality of the connection using burden measurement. So you get these pre-wired cans, right? And a lot of the utilities have assessed, you know, the time and labor rates for men and everything. And they've said, hey, you know, we're going to start purchasing these pre-wired meter sockets and meter cans, because in that way it saves that amount of labor and the installation's quicker. And so typically they are wired through the meter all the way down to the top of the test switch, right? So then all you have to do is come in and make the connections into the bottom of the test switch coming from the service. So all that is pre-wired. But they're not always wired correctly. I mean, they tell you they test them, but if that happened, then I wouldn't hear any of the stories that I hear from people out there in the field that they have gotten a pre-wired meter socket that wasn't correct. So we know it's not always correct, and we're going to show you a way to verify it before you carry it out in the field and install it and get it on there and then find problems. Okay, so here's a way to actually, and that's the way I'm going to do it. I'm going to have it just sitting right here on the tabletop, and I'm going to do a verification of it, all right? So let's take a look at, first of all, I've got a 7 series here. And you've heard me do this before when we've done load boost tests and done other tests where we've used the load box on the 7 series. This one has a 20 amp load box. It's a 7332. The 2 on the end designating that it has a 20 amp source. You can also get one with a 50 amp source, which would be a 7335. That second 3 also designates that this particular unit has a voltage source as well. So then that means I can provide voltage and current, so I can have just what I've got, which is a pre-wired meter socket sitting up on top of a table, and I can actually provide voltage and current to it to power it up and simulate the service that would be out in the field that you would connect it to. So what I'm going to do is I'm going to choose number 2, manual load box control here, okay? And I'm going to hit enter. So remember, since this is and I go up here at the top, it's just habit, I always go down to a 3-phase 4-wire Y. The auto detect, some people use that. I'm just particular, once you know how us field guys are. Once we get something that works, we want to stick by it and do it the same way every time. So that's what I do. So I just go right here, and I have chosen a 3-phase 4-wire Y, 3 voltage, 3 current transform rated service is what we're going to generate here. And then because it has both a voltage and a current source, I can make adjustments on the voltage side and on the current side here. So I can change my angles if I want to. We're always going to remember you can't change the 0 because that's our reference. We talked about that in the last webinar if you remember. That A phase voltage is our reference that we reference everything off of. If you remember the last webinar where we had that 6S with a Z coil, when there was a problem on it, everything rotated around that A phase voltage, right? So that you can't change. That's why it's grayed out there. That's our reference. But you could change B and C if you wanted to and change the angles on the voltage there. Typically what I do when I'm at meter schools or I'm training or whatever, I make an adjustment over here on the other side on the current. I leave the voltages at angle-wise. I leave them at 0, 120, and 240. I could also change the amplitudes on the voltage, okay? But I'm going to leave that at 120 for this. But over here, typically you've seen me, I will change those to like 10, 130, and 270. That's because I give a 10-degree separation between my voltage and current vectors on each phase of A and B. Then I typically give a bigger one on C to show the larger that angle, the worse my power factor is. So it demonstrates I should have pretty close of the same power factor on A and B phases, but it'll be worse on C because I've made the angle 30 degrees instead of 10. Okay, bigger the angle, the worse the power factor. So what we're going to do on this one is we're going to generate 5 amps on each of the 3 phases here, and I'm going to leave it at unity, which is 0, 120, and 240. So I'm going to leave these angles are the same between my voltage and my current, which that looks like unity on the vectors. They lay on top of one another, which of course you never see in the field, and that's why a lot of times I'll separate those when I'm doing training. But for this, we'll just leave them. Okay? So now I'm going to go ahead and hit start here. When I do that, it'll go through an adjustment phase, and then it'll say on, and it'll go green. Remember, we're big on red's bad, green is good. So while it's adjusting, you need to wait and wait for it to adjust and become green, and it'll say on. Okay, so now we know we're good. So we're generating that service that we're talking about, okay? So let's come over here to our can. So this is a pre-wired can. It's a 9S. I've got a 9S meter in here, okay? And you can see here, put my gloves on. So what we've done is, you can see, if you guys have ever tested in a substation where they want you to open everything up and then apply your voltage and your current there, that's what we're doing here. We've opened up all of our voltages over here on the left, A, B, and C phases, and we've come around to the top because I have to, because I've opened these switches up. So once I open them up, I have to make my connections at the top to drive the voltage to go up into the meter. So that's what I've done. So I've connected A, B, and C phases right here. Okay, so those are going into the meter. I've opened up my switch here. Now it's a little different than what we do at the substation, because at the substation I would open everything up here and then I would drive, right? I would put my insulators or isolators in here rather, and then I would drive top and bottom, and I would open my switches up so I don't get any back feeds. And that is, of course, the reason for opening everything up at a sub. Back feeds are bad. They can cause alarms to go off, and the guys with the different colored hard hats show up and want to know what you're doing. But what we're doing here is we're coming across the bottom here. So you can see I've got my red, yellow, blue, A, B, C on the drive, which goes up in here through my shunts. And then I've got my white connections here. So I'm using a current cable that instead of having duckbills on it, it's got alligator clips to provide the current. So in doing so, I'm going return, return, return here, and I'm going drive, drive, drive here. The reason I'm doing this for two reasons. Number one, I want to test that test switch from top to bottom, right? So I'm leaving this closed, and if I don't have a duckbill stuck in here, then it will still flow, because remember, when I put the duckbill in there, it causes a separation, and it causes me to go through the white and the black of the duckbill. Okay, so here I'm leaving the current going through so that I can test the test switch from top to bottom, make sure there's no problems on the test switch. And the other is it makes it convenient here in a minute where we're going to use the 3 series for verification to put in my duckbills right here. Okay, so those are the connections I've got. I've got my voltages here, and I've got my currents here. Okay, so now what I'm going to do is I'm going to take the 3 series that I have over here, and what I'm going to use the 3 series for is I want to do a vector. By using the vectors here, I can check for phasing problems on this pre-wired meter socket. Okay, so that's what I'm looking for, to make sure I don't have any phasing problems first. Okay, I'm also going to look at connections here in a minute, but first I'm looking at the voltages. So what I'm going to do is I'm going to take my duckbills. I'm going to open up my shunts like we always tell you to do for safety purposes. And I'm going to come in here and I'm going to go red. I'm going to go yellow. And I'm going to go blue. And then I'm going to close back in my shunts. So I have current flow through there, right? And then I need to come in here with my alligator clips for my voltage. And I'm going to go across the top. I have to go across the top as well. So I'm going to go right here, and I'm going to connect on my neutral. And then I'm going to go red, yellow, and blue. So I'm going to go red. I'm going to go, wait a minute. I don't like the way that's wrapping around like that. There we go. I'm going to go red. A phase, yellow on B phase, blue on C phase. Okay? So, just as we always talk about in all these webinars, we want to see the same thing the meter's saying. Well, so since I'm driving and generating right here my voltages, and I'm connecting right here at the same point, I'm going to see the same voltages that the meter's that's the meter's seeing from my 7 series. So I'm going to see that. You can see my neutral connection right there. Then these duckbills are going to allow me to see the same current. Okay? So, let's go over here and take a look and see what we see. So, hopefully there's some people in the chat room right now that are saying that doesn't quite look right. So what do we see here that we don't like? It looks to me like, and from all the webinars that we've done, you've seen what cross-phasing looks like, right? When I have vectors on a phase, which let's look here at A phase, there's my A phase voltage, I have the yellow or B phase current on it. I should have my red A phase current over here, so I should have red, red, yellow, yellow. Instead, I've got my B phase current is over here with my A phase voltage, and I've got my A phase current over here with my B phase voltage. So it looks to me like I've got cross phasing on A and B. So let's start taking a look at the socket and see if we can see where the problem is. We're going to come over to here. So I'm looking at the wires going across the top, because remember, all they did was wire it to the top of the test switch. So what I want to do is go across the top of that test switch and see if that looks right. So I've got, if my colors are correct, I've got red, yellow, blue. So my voltage connections to the top of the test switch look good. Red, yellow, blue. Let's go over here to my current side. And I've got return red, return yellow, return blue. So from a color standpoint, everything looks okay. Then I can look at my actual returns here, and that return comes here. A goes in there, B goes there, C. My C return wire comes over to C. So that all looks correct. So everything looks good at the top of the test switch. Okay? I've got my returns coming from the bottom of this meter right here, and they go into, from left to right, they go A, B, C. And then looking here at my currents coming in, I've got red, yellow, blue. So everything looks okay on my current side, and everything looks okay over here on my voltage side. So let's go to the top and take a look. Okay. So you can see where I leave out of here and go red, yellow, blue, right? But if I look right here, I've got yellow, red, blue across the top, which makes sense from what we saw in the vectors, right? The vectors showed us a cross phase on A and B, and that's what I'm looking at right here. My red and my yellow wires here are incorrect. I've got cross phasing right here. So we have now determined what the problem is, so now we need to correct the problem. So what I'm going to do is I'm going to, what you would do, right? You would disconnect it from the service somehow before you start pulling meters and doing stuff. So I'm going to turn off the 7 series, and then I'm going to pull the meter, and I'm going to correct these two connections right here, and then we're going to look at the vectors again and re-verify. All right? So that's what I'm going to do now. So I'm going to go over here and hit stop on my 7 series. And I'm going to, since it's dead there, I'm going to take my gloves off to do my screwdriver work. No one give me too hard a time about that. I'm going to pull the meter. Okay. So I'm going to come in here and I'm going to swap these back. So I will swap back the yellow and the red. Snug her down. Just like we deal with in the field, of course. It's going to come out of there. So now I'm going to put B phase back in there. Snug her down. Okay. I'm going to put my meter back in. Okay, so now, gloves back on. Okay, so now we're going to turn the 7 series back on or reconnect our service. Like we said before, adjusting, it's red, it's ready to go, it'll be green and say on. Very nice. On. So I'm good. So my service, I'm back connected to my service after I've made that correction on that wiring. So now I'm going to come back over here and look at my 3 series screen. Now that looks a lot better. I've got my red with my red, my yellow with my yellow. I've got the same secondary voltage and current together on that phase on A, and the same secondary voltage and current on B phase right here. Okay? So now I've verified the phasing's okay. I can also do a test with the 3 series. It does that burden measurement test that we've talked about, right? And it's unique in the industry. No one else can do that. So what it can do is it can actually measure the burden in each phase. So if I saw an excessively high amount of burden or resistance, that would tell me I've got a loose connection or something's not right in there, okay? So we're going to have to move our connections over here at the test switch to perform the test. So here's what we're going to do. Our voltages are right here across the top, right? So I'm going to move these voltages now. I'm going to move them over here because I'm measuring there and back, right? So what I'm going to do is I'm going to come at the top of each one of these duct bills, and I'm going to go red, yellow, and blue. Okay? So using the duct bills and using the voltage connections, remember we've talked about this in the webinars, we do the old V equals IR. Okay, so if we can measure the voltage there and back, and we can measure the current there and back, then we get the resistance. We measure the resistance. Okay? So, everybody see those connections? So I've moved it to the top of the duct bill, to the top of the duct bill, and to the top of the duct bill. Okay? So now let's go over here. And we will do a burden measurement test. And we're just going to leave the length 0 because, I mean, as close as everything is right there on top of one another. But let's take a look and see. So you can see how small the amount of resistance is. It's only 0.0687. Okay, so we're pretty consistent at 0.06 ohms. Okay, and it is number 12 wire. So we had we had put the wire size in there. So we put number 12 wire in there. We put the number 12 wire, and we made the connections correctly. It's literally telling us that we've got 0.06 ohms resistance in there, which that's going to be fine. If I saw some big numbers, that would concern me and make me think that I had gotten the pre-wired socket, and unfortunately and I've heard this before, guys tell me, you got to check those connections. You got to really check the connections on there. And you do have to look at phasing. I mean, it has happened. I mean, we're human, right? We make mistakes. So you could get one that would be incorrect or have a loose connection, and we would have gotten a large number of ohms here of resistance on any of the 3 phases. Okay? But we didn't in this case because everything was tight on here and everything looks good. So we have actually verified not only just the phasing of the socket and make sure that there weren't any, and we did see that there was a problem there initially, and we corrected that. But then after that, we also could test all of the connections utilizing the burden measurement feature of the 3 series. All right? So hopefully this is something that you guys can utilize before you carry one all the way out there and have to deal with it in the field. If you have a 3 series and a 7 series, you could do that. So you could, or if you had if you had some other way that you could power up that socket, you may have had some homemade deal that you figured out and you've built yourself over there at the utility, and you have a 3 series, you can check all the connections in there before you carry it out. Okay, so you can use one or the other or both. Like I said, if you've got something that you can connect to at a service, I know a lot of the utilities have a service available. They've got there in the meter shop, they've pulled in there and got there themselves. If you can use that to power it up, you can use the 3 series to check the burden measurement, or if you want to and you have both, you can use the 7 series to check to drive the thing and power it up, and then you can do the check with the 3 series both on the phasing and on the burden measurement. All right? We really appreciate everybody tuning in today. This wasn't a long one, but I thought it was pretty cool, and it's pretty neat when you can use the equipment and before you get out in the field, because we know when it's out there and it's scalding hot, like it's been here lately, and you run into problems like that, I'd rather go ahead and get everything worked out as much as I can in the shop before I load up in the truck and head out there. So with the equipment, you have the capability of doing a pre-check on everything and a pre-verify before we actually carry everything out in the field, all right? And we will be announcing here soon what the next Tuesday, where we're coming up on Tuesday. And Jarrett's really good about getting, if you want to show some of your folks this, of course it's going to be available on YouTube or on our website. So you can look at this and show it to somebody if it's something you might be interested in utilizing at your utility. So we just, once again, really appreciate you guys. Thanks for all of the support and everybody tuning in. And once again, utilize us. If there's anything that you want to see, let us know. Okay, just give us a holler and we can pull up, like I said, I just got one yesterday, a particular thing somebody wanted to see. So just let us know and we'll be more than happy to do it. So as always, be safe out there. God bless and thanks.